This is the 6-6 geometric sequence lesson. Today's objective is that you can write and find terms in a geometric sequence. So to start off, a couple things that we kind of need to address. One is what an arithmetic sequence is. Arithmetic, and this should be a little bit of a review at from when we learned about these before. So an arithmetic sequence, this is where it seems to add or subtract. It's an adding or subtracting pattern. And the general form for this is a sub n equals a sub 1 plus n minus 1 times d, where a sub n is the value of the term that we want, a sub 1 is the first term in the sequence, n is the number of the term that we want to find, and d is our change. This is different from a geometric sequence, because a geometric sequence, as you might be able to guess given what we're studying right now, and kind of how exponential equations work, is when it seems to multiply or divide. So it's a multiply or divide pattern. And so we have a sub n equals, this is the general term, a sub 1 times r n minus 1. A sub 1 is our first term. R is our pattern. And it's going to be some type of multiplication, just like whenever we're doing the exponential functions. And n is our term number. And so we have a couple examples in order to help us kind of figure out, all right, is it arithmetic or is it geometric? And so for number one, if I go from 120 to 60 to 30 to 15, and these dots afterwards just say the pattern continues, we go, okay, to go from 120 to 60, I'm either doing one of two things. I'm either subtracting 60 or I'm dividing by 2. And then I check the next one. I go, okay, I'm going from 60 to 30. And so I'm subtracting 60, or I'm not subtracting 60, I'm subtracting 30. So the subtraction method doesn't work out. So am I dividing by 2? And yes, I am. And to go from 30 to 15, I'm dividing by 2. And it is important to check every single one. A lot of times you'll just get some random number in there that breaks it, and so it doesn't work. And so this is geometric. And the change, our pattern, is 1 over 2. And because it needs to be multiplication, so dividing by 2 is the same as multiplying by a half. So we want to find the next three terms in this. So 15 divided by 2 is 7.5. 7.5 divided by 2 is 3.75. And 3.75 divided by 2 is 1.875. So those are the next three terms that we have. All right, let's look at number 2. Number 2 goes 2, 6, 11, 17. So we go from 2 to 6. This is adding 4 or multiplying by 3. To go from 6 to 11, we're adding 5 or nothing. And it kind of seems, it has a pattern of adding, but it's not the same pattern. We're not adding by the same each time. And so this is neither. Following the pattern that we kind of do see exist, though, we could probably guess that the next one might be 24, because we're adding 7. And the next one we might add 8, so 32. And the next one we add 9, so 41. All right, let's try number 3. 5, 1, negative 3, negative 7. Dot, dot, dot. And so to go from 5 to 1 is minus 4 or dividing by 5. 1 to negative 3 is minus 4, and the division of 5 doesn't work, so minus 4. Negative 3 to negative 7, minus 4. So we do keep the minus 4 continuing on. So if I do the next 3, negative 11, negative 15, negative 19. And so this is arithmetic. Arithmetic. It's an arithmetic sequence. And kind of a good indicator for this is if you have some, if you go into the negatives or you go from negatives to a positive without it kind of alternating back and forth, it's a pretty good indicator that it's not geometric. All right, number 4. 1, 0, 2, 4, 1, 28, 16, 2. And so with this, it can be kind of difficult sometimes to be like, how do I go from 1024 to 128? And so a lot of times I actually might work backwards. If it's something like this where I'm like, I just don't inherently know how to go from there to there. How do I go from 2 to 8 or 2 to 16? I multiply by 8. But I'm going actually the other way, so I divide by 8. And so I go, okay, what is 1024 divided by 8? Oh, it is 128. How do I go from 128 to 16? I divide by 8. And so we do have a pattern here. And so that makes this geometric. And if I do 2 divided by 8, I get 0.25. If I divide that by 8, I get 0.03125. If I divide that by 8, I get 0.0039, approximately. Okay. All right, let's look at number 4. Oops, that was 4. I'm at number 5. Graph the geometric sequence. So for number 5, we have this sequence. We have 32, 16, 8, 4, and 2. And it might continue past that. And kind of the thing that we have here is we kind of need to identify, how does this work? How do I graph this? And the reality is, on a graph, or at least the graphs that we know of right now, is these need to have an x and a y. And so I'm going to give them an x and a y. And traditionally, you're going to have your x's kind of going along the bottom, and those are going to be the things that are kind of changing consistently. So changing being like increasing by 1 each time, because we're looking for the different numbers of terms. And so I'm going to call this first one 1, and 2, 3, 4, and 5. And so we kind of have a little matching pair here. So go ahead and draw a... Actually, I don't need the whole thing. I just need this area. Let's see. Well, we'll go by 2s, maybe. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Whatever. We'll make it work. Alright, so 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Yeah, that really didn't work. Let's just make this one more time. Shapes. I think it's still going to kind of go off this a little bit, but 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I'll make this blue. 32, then 16, 2, 4, 6, 8, 10, 12, 14, 16, 3, 8, 2, 4, 6, 8, 4, 4, 2, 4, 2, 2, 2, 4, 8, 16, 32. 1, 2, 3, 4, 5. Alright. Graphed. Let's do another one. Let's do number 6. So if I'm given the sequence 1, 3, 9, 27, again, these are going to be my y values, and my x values are going to be 1, 2, 3, 4. Draw a graph. Luckily, it doesn't need to go as high, but we're just going to keep it the same. Blue. So 1, 1. Oh, nope. I'm going to do these by 2s again. That way it fits on my graph. 1, 1. 2, 3. 1, 3. 3, 9. 2, 4, 6, 8, 9. 27. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27. 1, 2, 3, 4. Okay. So now it fits. Okay. So as we talked about, the equation for a geometric sequence is a sub n equals a sub 1 times r n minus 1. And we talked about already that a sub 1 is our first term, r is our change, our pattern in multiplication terms, n is our term number that we're trying to find, and a sub n is the value of the term. So for number 7, write the nth term of the sequence, then find the 10th term. So on number 7, I have 2, 12, 72, 432. So I want to find my pattern first. So how do I go from 2 to 12? I multiply by 6. 12 to 72, I multiply by 6. 72 to 432, I multiply by 6. And so a few key features that I can get out of this is that my first term, my a sub 1, is 2, because it's my first term. It's right here. The second thing that I need to figure out is that my rate, my change in multiplication, so I'm multiplying by 6. That's a whole number. So in order to find the nth term of this, so just kind of the general, if you will, terms, so a sub n, that's going to be this 2, because that's my first term, times the rate, which is 6, raised to the n minus 1. All right. Now to find my 10th term, all I'm doing is I'm changing out 10 for anywhere that I have an n. So I go 2 times 6, 10 minus 1. So this is 2 times 6 to the 9th. And if I plug that into my calculator, I get 2015539.2. If you want some commas there. And so you can kind of see how just taking it and plugging it into a calculator might be a little bit easier than trying doing it by hand. I definitely wouldn't expect you guys to do this necessarily by hand. Maybe get to this point by hand, but actually evaluate it by hand, not so much. But as you can see, it does kind of make it a little bit simpler. All right, number 8. So if I go 1, -5, 25, and -125. Now we talked about this, I mentioned it I guess really, is that it's alternating from negatives to positive, which is totally fine, as long as it's alternating. If it's not alternating, it kind of is like an indicator of like, it's probably not geometric, because you have like a squared and a not squared idea. So the question is how I go from 1 to -5. I can multiply by -5. And from -5 to 25, I can multiply by -25, or not -25, -5, -5, and then from 25 to -125, negative 5 again. So my a sub 1, my first term is 1. My rate, my pattern, my multiplication pattern is negative 5. Now I need to figure out the nth term. So my nth term, a sub n equals 1 times negative 5 n minus 1. And to put a little more practical application to it, I want to find the 10th term. So a sub n equals 1 negative 5 to the 10 minus 1, which is, well, I can just leave off the 1 at this point. Negative 5 to the 9th. And negative 5 to the 9th is negative 1,953,125. So 1,953,125. All right, that concludes our 6-6. Check with your teacher on what your assignment is. Have a good one.